Hello students, welcome back to chemistry online class brought to you by Iupac virtual learning platform. I still remain your chemistry tutor, Mrs. Olawe Olabisi, and this platform is meant for treating past questions based on the WAEC syllabus and treating important topics in chemistry backed up with WAEC past questions. So at the end of this class, you're expected to be able to go through past question based on the topic treated. And the topic we are treating today is formation of stable compounds from ions and naming of compounds. You are expected to be able to form compounds from ions and also name simple ionic compound. Now, ions are formed by either gaining or losing when atoms of element gain or lose electron, and compounds can be formed from these ions by exchanging their radicals, by exchanging their oxidation number. That's their oxidation number. Oxidation number is actually the number of electron gained or lost in a reaction. So at times oxidation number can also be equal to the valence electron of some element, though they are not the same. Valence electron is the number of electrons at the outermost shell of an atom. Consider calcium, which is 20. Atomic number is 20. Arranging the electrons, we have 2 on the first shell, 8 on the second shell, making it 10. The third shell is 8, that's 18. The last shell is 2. The valence electron is 2. But the last shell is supposed to be 8, so it has 2. It's in need of 6 more. Gaining 6 will be difficult, but it's easier giving out 2. So such element that gives out 1 valence electron, 2 valence electron, or 3 of their valence electrons are becoming electropositive and they are metallic in nature. So they are going to become electropositive, changing from atom to ions because they are giving out, and it is common among elements with 1, 2, 3 valence electron. So the oxidation number of calcium here is 2. So you see calcium written as Ca2+. Now, if you are asked to form a compound between calcium and chlorine now, just work out the oxidation number of the two, exchange it if they are different, then if they are the same, you cancel out. Now for chlorine now, which is 17, 287. That's the oxidation number. In this case now, 2 of chlorine is combining with calcium because chlorine is 1, so and calcium is ready to give out 2. So 2 of chlorine we take, and that is complete transfer, not sharing, and that's ionic bonding. In this case now, the oxidation number has been written on top of them, then exchanging their valency. By the time the number comes down, 1 does not really make it is not really important here, and the signs too will not be noted because whatever number comes down represent the number of atoms, but if they are up, they represent oxidation number. So this one is coming here, which is negligible, so we write CaCl2. The next example here is between nitrogen and hydrogen. Nitrogen here is 7 and hydrogen is +1. The oxidation number, the atomic number of nitrogen is 7. That's what I mean. And arranging it, we have 2 and 5. The first shell takes 2, the second shell takes 5. Arranging it like that, 5 is actually 2, 1, 1, 1. So nitrogen is in need of 3 more to make a stable octet structure outside. And hydrogen has just 1. And the oxidation number is +1. So nitrogen is gaining 3 instead of losing 5. That's 3 minus. That's the oxidation number. Exchanging this, we have ammonia. Other examples are here between potassium and oxygen. Potassium is 90 and oxygen is 8. When this is arranged, potassium will end up giving out, that's 2881, gives out 1. Oxygen is in need of 2. They exchange their valencies, and then we have potassium oxide. Others are potassium chloride, that's between potassium and chlorine. Chlorine is in need of 1, potassium is giving out 1. So in this case, they cancel out because they are the same. This is +1 and this is -1, which you cancel out to give a neutral compound. Other examples I would like you to work out is between aluminum and chlorine. Anyway, the answer is here. Aluminum is 13 in number, that's the atomic number, and chlorine is 17. That's arranging aluminum, we have 283. The 3 valence electron is given out as 3+, while chlorine is taking 1. So 3 of chlorine combined with 1 aluminum. In this case now, exchanging their valency, we have AlCl3. The 1 is coming down here and is negligible. Now, another important example here is between magnesium and tetraoxo-6. Magnesium is +2. Tetraoxo-6 is a radical. Tetraoxosulfate 6 ion is an ion, and this ion usually have charges. We have other examples of radicals: NO3 minus, CO3 2 minus, and so on. It is your responsibility to learn the charges that each of these radicals carries. You should learn their charges and memorize them. So here now, magnesium is carrying -2 because you have to write the compound between magnesium and tetrose of a 6. So this is +2 because magnesium is 12. That's 2H2 plus 2. Why is tetrose of a 6, which is a radical, is carrying -2? Sorry. So by the time you cancel them out, because they are the same, you end up getting magnesium tetraoxosulfate 6. And the last one here, in case you have a monovalent element, where sodium is carrying +1 because it's 11, 281 is giving out 1, that's +1. While CO3 is another radical that carries -2, you exchange it to have Na2CO3. Another important part of this topic is assigning oxidation number to chemistry. There are so many rules for assigning oxidation number to elements and the naming of compound itself. The first part here is using Iupac nomenclature to name compounds. It's very, very important. And Iupac here means International Union of Pure and Applied Chemistry, and it is important that we know the oxidation number of elements before we can use the Iupac method to name elements. Before the old methods was used, if for instance we want to mention or you want to name calcium tetrosulfate 6, it is named as calcium sulfate. That's the old name. But for students, white students now, you're expected to write the name in full with using the Iupac nomenclature. So oxidation number are assigned based on these rules. The first one here is a single element have oxidation number of -1. That's based on their ions, the charges that their ions carry. You know, atom is different from ions. Atoms gain or lose and they become ions. So when they are ions, like this Fe3 plus is the ion 3 ions, the oxidation number is +3, and so on. So the oxidation number of hydrogen in a compound is always +1. But in cases where it is combining with another metal, like metal hydride plus, the oxidation number of hydrogen will be -1. The oxidation number of oxygen in a compound is always -2, except in peroxides, that's H2O2, where you see it combining with other elements to form peroxide, where you have the same number of atoms, it is -1. Take note of this exception before you name or calculate the oxidation number of elements. The oxidation number of an uncombined element, like a molecule of nitrogen, oxygen, they are what? They are 0. Chlorine and so on, without carrying any charges on them, they are always 0. Then for neutral compound, as is any time there is exchange of valencies to get a compound like sodium chloride, the oxidation number here is +1, that is -1. They've cancelled out, and their total oxidation number is equal to 0. And for polyatomic ions like CO3 2 minus in a radical, for instance, the oxidation number is equal to -2. That's the net charge on it. Like SO4 2 minus now carries the oxidation number of -2. NO3 carries the oxidation of -1 as the overall charge. There are other things that you need to know when naming the compounds, like binary compounds. They always end with "ide" except in water and ammonia. Like binary compounds, that means they contain 2 elements. You know, a compound is made up of 2 or more elements chemically combined. And this is a radical, it's not a compound, because it's made up of 2 or more elements doesn't make it a compound. Because it's carrying charge, it cannot exist alone. It forms part of a compound. You see it in compound like H2SO4, MgSO4. So this is a radical. Radicals cannot exist alone. They form part of a compound. But these compounds now, they are binary compound because they contain 2 elements. Their names end with I, like potassium chloride, hydrogen bromide. And another important aspect is when naming metals that have variable oxidation number, that you have more than one oxidation number, you have to write the oxidation number in brackets in Roman figures. But for elements that does not that have only a fixed oxidation number, like sodium, potassium, and so on, you don't write their oxidation number in Roman figures. A very good example of elements with variable oxidation number is iron, iron, copper, and so on. So we write copper 1, copper 2 oxide, copper 1 oxide. We specify iron 2 oxide. Now that leads us to how to name compound using WAEC past questions here. I'm going to quickly explain how to name a compound. And this is done by targeting the oxidation number first. You need to work out the oxidation number of that element before you can name, before of the central element in the compound before you can name the compound. I'm going to start with this example. Write the Iupac name for each of the following compounds. This is WAEC 2015 theory. NaClO3. We have to write the Iupac name for it. What you do is to target the central element, which is chlorine. Haven't done that, then let's assign oxidation number. Sodium is 11281. It gives out +1, plus this chlorine we want to calculate, plus oxygen is 8. Atomic number is 8, 2, and 6. That's how to arrange it. In that case, it's gaining 2. That's -2 of oxygen. That's the oxidation number of oxygen, multiplied by 3, because in the question we have NaClO3. So multiply by 3, everything is equal to 0. By the time we work this out, we have chlorine as 5. So that is, now naming the compound, we start with the first element, we go to the last element, then we name the central element last with this oxidation number. So in this case now we have sodium. 3 means tri, 4 means tetra, 2 means di, 1 means mono. So this is sodium trioxo, that's trioxygen, trioxo chlorate, from the word chlorine, trioxochlorate 5. And the 5 that we got is from the oxidation number and is written as V in Roman figure, sodium trioxochlorate 5. Another example here is a pentahydrate compound. That is an hydrated compound here. It's still WAEC 2015. Where we have copper sulfate .5H2O. Here now the oxidation number of copper is +2, plus sulfur that we want to calculate, that's the central element, plus then oxygen is -2. From the atomic number, working it out, you have 2 on the first shell, 8 on the 6 on the second shell, which gains 2 more to make it a, that's why it's negative -2 times 4, because we have 4 atoms of it. Everything is equal to 0, leaving this one aside. So working out the oxidation number of sulfur here, we have 6. So that is copper 2, because it has variable oxidation number, copper 2 tetraoxosulfate 6. Now this 5H2O means penta, 5 pentahydrate, because of the water crystallization here. And in this case now, the question is H2SO4. Determine the oxidation number of sulfur in H2SO4. You follow the same method. Hydrogen is 1, multiply it by 2. The oxidation number of hydrogen is always 1, multiply it by 2 in brackets, separated from the sulfur, plus then oxygen is -2, that multiply it by 4, everything is equal to 0. Working out the oxidation number is 6. So from there we can even name the compound as tetraoxosulfate 6 acid, because acid is denoted by the presence of hydrogen at the beginning, or we name it as hydrogen tetraoxosulfate 6. Now, if you are to name, determine the oxidation number of sulfur in this compound. I deliberately left the first question here because this is more similar to what we are doing here. Determine the oxidation number of sulfur in Na2S2O. That is why 2008. We are to find out the oxidation number of sulfur. So assigning oxidation number to all of them, we have sodium taking 1 multiplied by 2 plus 2S, that's the 2 of sulfur, plus -2 of oxygen times 3. This is 2 plus 2S plus -6. Everything is 0. That is 2 plus 2S minus 6 equals to 0. 2S equals to 6 minus 2. 2S equals to 4. Dividing both sides by 2. Sulfur takes 2 as the oxidation number. Then back to number 1 question. WAEC 2013 number 3. The formula of the compound formed between a trivalent metal, that is trivalent metal carrying +3, and a divalent non-metal. Why? A non-metal is always negative, the gain. Why metals gives out? That's 3 plus and Y2 minus. Exchanging their valency, we have M2 Y3 because that's the rule in forming a compound. Any formula you are given is what you should use, any letter you are given, except if you are asked to state the name of the element. And the last question here is an atom of an element X gains 2 electrons. The symbol of the ion form is what? Whenever element gains electron, they become positively charged. They change from atom to ions, and that's why 2013 number 4. So we have X2 plus as a breast sensor. Thank you for the class. Watch out for the next Y questions, and I will advise you to treat more questions based on these topics treated so far. Thank you. God bless you.